You know what? I'm gonna rub the entire board for this. I'm just going to write a big. Okay, so this is another Stanford math tournament problem. This is from last year's algebra problem set, 2021 for reference. And I don't remember the question number again, but yeah. So the question basically says that x, y, and z are integers, positive integers, and 1 is less than x is less than y is less than z. So yeah, so an x, y, and z satisfy these two equations, right? And they've said that log base y of z is p plus root q over r, right? Which I've let equal to t. This is for later. You know what? We don't need it actually. Now that I think about it, but yeah, just a few minutes ago I had a go at this and I think I miserably failed. Yeah, that was. Yeah, but I'm just gonna go at it again. Never give up. So yeah, they basically said that this is the form of log base y of z e plus root q over r, right? And they've told us to find p plus q plus r. Okay, so this is quite an intriguing question. I quite liked it when I saw it first. It seemed simple. Okay, so first and foremost, we'll go ahead. You know what? I don't think we need these laws either. But if we do, I will state them later on. Because I don't want excess, empty, falsely, unnecessarily filled space on the board. So, yeah. So first of all, we'll assign values, right? So log base x of y. Because see, this is really complicated to write. So for convenience, we'll call this a. Then similarly, log base y of z, we'll call b. Log base z of x, we'll call c, right? That's for convenience. We really want it in that form. That makes everything much better, trust me. Okay, so now we'll go on solving the first equation. So we'll replace the stuff by a, b, c. Now we know that this is 8. I'm pretty sure this is as simple as stuff can be, right? This is in the best possible form. Now for the second one, we'll have to use a little trick, right? So first and foremost, so we'll have to use the trick that log base a of b equal to 1 over log base b of a. You can prove this using the change of base. What's it called? The theorem? Property of logs. Yeah. So yeah, that's what we're going to use for the second one. So yeah, so as we can see, this is x is c. So this is similar to zx, 1 over zx. In fact, log base 1 over 1 over log base zx. Yeah, that. And log base z of x is c. So we have 1 over c, and similarly yz zy. So that becomes 1 over b plus 1 over a, and addition is commutative, so it doesn't matter which pattern you write stuff in. Exactly, right? And that's great, right? Okay, that's really good. So that's a really convenient notation. Let's simplify this part. Right, so this is 1 done. This is 2 starting it now. So 1 plus 1 over. So yeah, we'll multiply the denominator. So a b c, and the top is a b plus b c c a. I think that's right. Yeah, I think that's right. Okay, 3 terms. Oh, yep, that's right. So that's 25 over 2. Right. Now for ABC, what we'll do is we'll multiply these out. So ABC, this is equal to, well, let's see, right? log base x of y times log base y of z times log base z of x. Right? This is really nice. So we can use the chain rule for logarithms. That is, don't go to calculus yet. So yeah, y, z, z. The last value is x. So x, we can say ABC is equal to log base x of x. Right? Therefore ABC, and because the base and the input are equal, we know that this log is 1. So therefore our second part 2 is AB plus BC plus CA, which is 25/2. And whilst doing this, we've created a third part. ABC is equal to 1. And this is really good, right? We have 3 equations for 3 variables. So that's quite cool. So I'm just going to rewrite all of them again. A plus B plus C is 8. AB plus BC plus CA is 25/2. ABC is 1. Well, that looks familiar. So that's in a cubic form, right? That's in the form of a cubic. Yeah, that's a cubic. So so I'm just gonna remind you the forms of cubics, right? So for a cubic, say this is an example, absolutely unrelated. For a cubic, ax cube plus bx square plus cx plus d equal to 0. For that we have and with the roots, say alpha, beta and gamma, say that those are the roots. So with those roots we have, because of course cubic equations have 3 roots, so yeah, with those roots we have right, so first the sum of the roots is it is minus b over a, yeah, then alpha plus beta gamma, the product of the, like, I don't know what it's called, but yeah, the product of 2 terms added, I guess, I don't know what it's called, times alpha gamma, yeah, is equal to c over a, and the product of the roots is minus d over a. Yeah, that's the general thing for, yeah, I think that's the general thing for cubics. So yeah, with that, and we can of course see that in here, right? So let's see. Let's consider a to be 2, right? Yeah, that makes sense. So let's form a cubic. So let's say a is equal to 2. Say a is equal to 2. So for oh no, sorry, I mean, like, sorry, I think I should take alpha for this one, right? Because then there's a very large ambiguity. I'm gonna rough this general things off because it's really taking up unnecessary space on the board. So yeah, yeah, so for this one, let's say alpha is equal to 2. Yeah, that's fine. Basically the coefficient of the x cube term is equal to 2. Say that's the case, right? Wait, I think I'm gonna do minus 2, right? Because if that's the case, wait, no, oh yeah, that's 2. The coefficient of the x cube term, let's say that's minus 2, because the denominator here, so we'll have a minus 16 for the b term. Okay, so let's form a cubic with this, right? So minus 2x cubed, right? Yeah, minus 16x squared, minus 2 minus 25x. Does that make sense? C over A, yeah, it makes sense. Oh wait, no, there should be plus 16x squared, I think. Because this is minus b over A, I mean. So minus 16 over minus 2. Yeah, minus cancels out. Makes sense. And the d part, the constant part, that should be okay. Let's see. So what over minus 2 gives us 1? Minus 2, right? Yeah, minus 2. So that's the cubic we have for now. Yeah, right. Now wait, I just realized I've created a massive ambiguity here. Let's use another variable. This is not the right variable. Because x is already in use, right? Yeah. Okay, x is already in use. So, you know what? Yeah, because this is going to overcomplicate the expression. So what I'm going to do is, I'm just going to take the first coefficient of the x cubed term is 1, because that's going to make it like much more simpler to see, I think. Right? Yeah. So, okay. So we have minus b over 1. So that's, well, first of all, okay, let's see, I don't know. Let's use s, because p, q, r are already in use. So s cube, because, the first coefficient is 1. Then, okay, so the sum is supposed to be minus b over a. So a is 1. So minus b, what is that, minus 8? Yeah. Minus 8s squared. This is supposed to be c over a. So that's just 25 over 2 plus 25 over 2. Is that in frame? Yep, that's in frame. S and minus 1. Yeah, that seems about right. Yeah, that's about right. I don't know, let's call this q of s. The polynomial q of s is that. And a, b, and c are the roots of this polynomial q of s. Okay, that makes sense. So, okay, so wait, yeah, I think, what do we do? Okay, let's factorize this, right? So, there anything that's like already visible or something? Okay, so for cubics, okay, we have s cubed. Let's say s cubed is and minus 1. So the factors of minus 1, no, that doesn't make sense. I'm gonna try s equals 2, right? And see if that's, because then if q of 2, say, is equal to 0, that implies that no, s, yeah, sorry, s minus 2, yeah, s minus 2 is a factor. S minus 2 is a factor, if that's the case. Now let's make the implied sign here. Implies that, yeah. Okay, so, okay, let's try. Right. That's 8 minus, okay, no, that's in frame. minus 8, 2 squared, 25 over 2 times 2, these cancel out, minus 1. Okay, now 8, so these is just 8 minus, so 8 4s are 32, and plus 25 minus 1. So 8 plus 25 is 33, and 33 and 33. Well, yeah, that's 0. So now I'm gonna move to the other side. Okay, so now we know that, let's just see that in the end. Let's just say, so that implies that Q of S can be written as S minus 2 times something times some K. Okay, let's find that K, right? So that K, as K is equal to our original polynomial in the natural form, S cubed minus 8S squared plus 25 over 2 S minus 1 over S minus 2. Okay, that wasn't in frame. Yeah, that's better. Okay, now I'm just gonna do division. S minus 2 S cubed minus 8S squared plus 25 over 2S minus 1. So S squared minus 2S squared minus, these cancel out, and this becomes minus 6S squared plus 25 over 2S minus 1. Yep, and that's minus 6S. Minus 6x, minus that becomes plus 12 plus 12 s, yeah, and then minus 6s squared. Those cancel out, so plus 12 can be written as plus 25 over 2. Oh no, plus 24 over 2. It's minus 24 over 2. Plus 25 over 2 minus 24 over 2, that's 1 over 2 minus 1. You know, and that's just 1 over 2 and s. Okay, so that's gonna be oh yeah, 1 over 2 s, sorry. I missed the variable. Okay, so that's just 1 over 2, yeah. I think that's a plus 1 over 2. So 1 over 2 times minus 2 is minus 1. Apologies, minus 1. And this is going to be 1 over 2s. These cancel out, and this is 0. So that's the division, right? Yeah. So in conclusion, Q of S, I'm gonna rub out the division because I consider that rough work. That's trivial. Oh, I rubbed out the, okay, hopefully my memory isn't too bad. Okay, so yeah, so our Q of S is equal to S minus 2 times, okay, the K was, let's see, S squared minus, was it 6s? 6s plus 1 over 2. Yeah, I think that's the, okay, so that's the right form, right? Okay, so now we know that 2 is one of the results of this polynomial, which means that 2 is one of the roots. So 2 is one of the roots, and remember that A, B and C are also roots, so we need to find all the roots, right? Okay, that's good. So let's see. I guess we can factorize this one, which is going to be annoying, but I'm going to use the quadratic formula maybe. Does that make sense? I don't know if it does. Yeah, this is annoying. Okay, so I think I'm just going to use the quadratic formula, right? So we know that S would be equal to okay, so minus b, that's minus is 6 plus or minus square root of b squared, which is minus 6 squared minus 4 1 1 over 2 over this is the denominator is 2a, so 2 pardon me. Okay, that makes sense. So S will be 6 plus or minus square root of, let's see, 36 minus, okay, so these cancel out, minus 2 over 2, 6 plus root 34 over 2, 6 minus root 34 over 2 S, right? So because those are the solutions, we know that S is equal to the product of those two. Yeah, that makes sense. So Q of S entirely factored out is equal to S minus 2 first and foremost. Okay, that's going to be, is it going to be 6S? No, it's going to be 6S, yeah. 6S plus root 34 over 2, 6S minus 34. Now, you know what? No, see, these are just the roots, right? Okay, so we know that the roots are okay, so one of the roots is 2. That's the one of the roots. Then the other root is 6 plus root 34, square root of 34 over 2, and then the third one is 6 minus square root of 34 over 2, right? Okay, and we know that, okay, we've been given that these this equality we've been inequalities we've been given this one. So okay, I think we can say that what is this? Okay, so 6 minus a little less than 6 over 2, 6 plus a little less than 6 over 2, so that's going to be the, okay, so both of these, this one's going to be less than this one's going to be the smallest one, I think. Yeah, that's one going to be smallest, which should be x, right? No, wait, the smallest one should be okay, let's see. So as for the smallest, wait, oh well, actually, I mean, this one's the smallest, this one's the largest, but see what the value of b is, the largest value, see, because y and c are both greater. Yeah, I think that's the case. Yeah, I think so. Now see, because of this equality, we can just say that, so I mean, yeah, the largest to the okay, so c is going to be the smallest one, right? By this inequality we can say that. And what's a, okay, let's see. Oh yeah, okay. And then the largest one is going to be b, and we know the largest one is this, so we know that b is 6 plus square root of 34 over 2. Oh goodness gracious. And we know that b, as we set it in the starting, okay, yeah, okay, where's b? God damn it, my brain. Okay, yeah, there it is. Yeah, so we know that b is equal to log y which implies, okay, wait, the same. Log base y of z is equal to 6 plus root 34 over 2. Okay, and we've been told that q, i.e. the number inside, isn't divisible by any square of a prime number. Okay, let's see the okay, it's 17 and 2, isn't it? Yeah, those are the only multiples of factors of 34. Pardon me. Factors of 34 are 117, 2, 34. Yeah, okay, so that makes sense. Okay, so this is so far accurate, you know? See, because, yeah, it makes sense to me, at least. Well, that's an achievement. Right, so, okay. Now we can just, okay, we had to find p plus q plus r, may I remind you. So, by inspection, we can say that p is 6 in frame, good, q is, let's see, 34, and r is 2. Okay, so this gives us log base y of z is equal to 6 plus 34 plus 2, which is, okay, so 42, 42. 42 is the answer. You know what, I'm gonna rub the entire board for this. I'm just going to write a big nice. I do not care about math. Math is least of my worries. The entirety of the right side of the board is gone, and I'm just going to write nice. Oh, I was writing mice apparently. Well. Yeah. You can just tell that I'm tired. Nice. An exclamation mark, perhaps. And of course, a big 42. 42. Yes. Yeah, I really relate to this problem. The meaning of life. Yeah, I'm gonna try to find some 6-9 problems now.